Alright, so we're going to do a bit of an example looking at the ionization of acids and bases and their conjugates, okay? So we're asked here to write equations, so we're going to write more than one, showing hydrogen sulfate ion reacting as an acid and as a base, and thus to find its conjugate in each instance, okay? So we know that we know that hydrogen sulfate can receive a proton and form sulfuric acid, or it can donate a proton and just be left as sulfate, okay? But the best way, if you want to find its conjugate in each instance, okay, then the best way to do this would be to write reactions showing hydrogen sulfate reacting as an acid and a base with water, okay? So the best way to find its conjugate is to write reactions where hydrogen sulfate is reacting with water, okay? So first we'll show hydrogen sulfate acting as an acid. Alright. So here we have hydrogen sulfate. Okay, we know that if the hydrogen sulfate ion is already in water, then it might look a bit silly to say that it's reacting with water, okay? But what we need to realize is that when we have any sort of acid or base in a solution with water in aqueous solution, it's actually a very sort of dynamic solution, okay? There's actually lots going on. It's kind of reacting, although it might look like a solution is just sitting there, there's actually sort of reactions and stuff going on inside, okay? Now, hydrogen sulfate is not on the list of strong acids, okay? So therefore, we know that this is weak, okay? And because it's weak, it doesn't react fully, okay? So what we're going to use are these funny looking arrows. These kind of show that the reaction does not occur to completion, okay? What this means is that, the reaction only occurs halfway, or, maybe all of it reacts and half of it reacts back. But basically the point is not all of the hydrogen sulfate is going to end up used up in this reaction, okay? So we use these double arrows with sort of half an arrow forward, half an arrow back. Okay, so now the product, if it's acting as an acid, we know that it's going to produce a hydronium ion. Okay, and so if it's lost one proton, then the hydrogen sulfate is going to turn into sulfate. Okay, and that makes sense because we know that this is the conjugate base of hydrogen sulfate, and so all we've done is subtracted one proton from it. Okay, so now if we want to do this, this is the conjugate base of hydrogen sulfate when it's acting as an acid. Okay, so that's the first part of the question done. We've written the equation and we've shown that it's acting as a conjugate base. Okay, now again, we can show it acting as a base. Okay, so just the same way that hydrogen sulfate wasn't a strong acid, okay, it's not on the list of strong bases either, so we're going to have to use this double arrow here. Okay, so if we have hydrogen sulfate here, and water, okay, then again we're going to have sort of this double arrow. Okay, and we know that it's acting as a base, so it's going to produce a hydroxide ion. Okay, and so the conjugate acid of hydrogen sulfate when it acts as a base. Okay, we're just adding a proton to it, we're adding a H+, okay. This H2O has become a hydroxide ion, so it's lost a positive hydrogen, okay. So we're left with H2SO4, or sulfuric acid. Okay, so this is a weak reaction. This is a weak base, okay. So we've got a partial reaction here, okay, and this is going to be the conjugate acid. Okay, and in this instance, we know that sulfuric acid is on the list on the left, and it's listed as a strong acid. Okay, and that sort of tells us something, because if we were to write this equation in reverse, if we were to start with sulfuric acid, it would go to completion. Okay, and what that means is that basically, while we can still say that this reaction does occur, and that we have the partial reaction arrows to sort of show that it doesn't react fully. Because we know that this reacts a lot, this reacts to completion if it reacts with water, this sulfuric acid, we know that this reaction is going to occur to a very little state, okay? So it's going to sort of move this way a little bit more. Okay, it's still going to happen a little bit if we add hydrogen sulfate, if we sort of mix hydrogen sulfate and water. It's still going to happen a little bit, but it's not going to happen very much at all because this is strong, okay? But these are the two chemical equations we need. Okay, and we've identified the conjugate base and the conjugate acid of hydrogen sulfate when it acts as an acid and as a base.